let's look at the case where the relative velocity are inclined at 90 degrees, right? Yeah, it's not going to be parallel like how we did it in the previous session, but in this session, the velocities are going to be inclined. And the very common one is when the velocities are inclined at 90 degrees. So let's solve that with examples. Let's look at this example. A particular body A is moving due east, right, at 4 meters per second, and B is moving due north at 3 meters per second. When we say due east and this thing, right, just make reference to the cardinal point that we know. Right here, over here, there, this is the north, this is the east, this is the south, and this is the west. We this is what we make reference to when we are making direction every time, right? So there are angles that are involved, but in this case, in this particular session, we'll be looking at the case where they are perpendicular. So here is 90 degrees, here is 90 degrees, here is another 90 degrees, and here is another 90 degrees. So we'll be looking at cases like that, so that the two velocities are inclined 90 degrees, and we solve them, unlike the previous session where they are all parallel, moving in the same direction or opposite directions. Okay, so how do we solve it? So this one is moving due east, right? You need to represent this one by an arrow. Due east, so east is towards this side. So A is 4 meters per second. A is 4 meters per second. And B is due north. North is the top, right? So this is 3 meters per second. Now they are no more parallel. So now they are now moving in inclined directions. So they say we should find the velocity of A relative to B. So the B is the observer, right? The second one that we have, velocity of A, meaning we are finding velocity of A compared to B, meaning how B is seeing A. We've done this in many times in the previous session. So this is represented as VAB, right? VAB. So the second one that you write is the observer. The second that you write is the observer. So we need to keep that in mind. And then this one is equal to VA minus VB. So this is what we have for this, right? This is the expression that we got from the previous session. From the previous session, if you listen to in parallel, right, it was easy to just plug in the values directly. But that's not going to be the case for inclined velocities. What's going to happen? You see that the B, right, there's a minus in front of the minus is affecting the B. So we focus on the VB, right? The minus should tell us that we need to take care of the minus first before we can include all of them. So then a minus on the VB on the B is just telling you that when you take the B, right, reverse the direction of each arrow. If it is moving north, move it south. If it is moving west, move it east. If it is moving east, move it west, right? So we need to take care of the VB first because of this negative. Then we bring them together and we see what they can form. Okay, so let's go to another slide, right? And VB is this, right? With a velocity of 3 meters per second. But then negative VB, you need to get negative VB is going to be the other direction, 3 meters per second. But the A is not having any B, so the A is still going to be the same towards the east, as we said. So A is still going to move 4 meters per second towards the east. So what we've done so far is just to make sure that we move from VB to negative VB. Why are we going to negative VB? Because the formula says VA minus VB. But for inclined vector, we cannot directly put in the values, right? But we need to actually make sure that this negative is read or is performed in such a way that the VB is now changing to negative VB first before we put them together. Now, next is to put them together. How do we put these two things together? It's not about taking the value straight, no, but it's about taking the representation arrow that we have drawn, right? Such a way that you have to first draw the observer, the one we are observing. So the one we are observing is this one, which is A, right? A, which is called 4 meters per second. And then this is VB. Keep in mind that you need to attach this diagram of VB to A such that the head of the VB, right, connects to the tail of the tail of the A. You have to connect the VB to the observer's velocity that you have reversed to the tail, such that its head, the head of its arrow, connect to the tail of the one that you are observing. Let me do it like this. Let me bring it down so that we can represent it well. So our VA, which is 4 meters per second, is here, but we need to connect negative VB to this, right? The reversed VB is now the one that you add to this, such that the head of the VB, so this is negative VB, the head of it, right, is connected to the tail of the other arrow, the VA. So this is the observer. Is the observer that we are manipulating. The one that we are observing is kept intact. We don't change it. We don't do anything to it. But then we first reverse the VB, draw the body that we are observing, and then we attach the reversed velocity of the observer such that the head of the observer is connected to the tail of the one we are observing. Now this will now form something, and then these two have an angle of 90 degrees in this particular case. Now, after doing this, now how do we find the relative velocity? Also, what we do to is what we do is that, let me redraw this line. Then you now have to close this. So close this triangle like this. If you close it, you have to make sure that you do double arrow on the this, and the arrow is towards from the tail, right? It's as if you are moving from here to here, then to here. So the resultant one will be from here to here, right? But the arrow will move from wherever it started from to wherever it's going to end, right? So you have to always move that arrow in that direction. Keep that in mind. So here, what we have here will be the VAB. This is VAB. Because this is a right angle triangle, right? We cannot be using VA minus VB straight. Now that you have this right angle triangle, you use Pythagoras theorem to find so the resultant is the hypotenuse. So the hypotenuse is equal to square root of the sum of the squares of the other sides. So it's going to be VA squared, right? VA squared is 4 squared plus VB squared is 3 squared. 3 squared. If you do this well, right? If you put it in the calculator, you are supposed to have 5 meters per second as your answer. So this is the value of the VAB. VAB. But we are not done. This is just the magnitude, but we have to find a direction. A direction, right? For the direction is the angle. It's now going to be in terms of an angle theta. Theta. That theta is between the observer and the resultant. Always in that corner. Always in that corner. The observer and the resultant. That's where you have to put the the direction. The direction is now, it should be an angle now, right? Okay, so let's find this theta and then finish up with this particular question. And in a right angle triangle, right, you can use tan theta. We know this side and we know these two, right? We can use SOHCAHTOA. So if you are talking about TOA, right, is tangent of theta will be equal to the opposite over adjacent. The opposite to this angle, is this 4 over the adjacent is the 3. Is the one that's directly connected to is the 3. Right? So tan theta is equal to 4 over 3. So theta is equal to tan inverse of 4 over 3. So in this case, we just basically need our calculator. Let me pull my calculator and then get the answer for you. But I hope you are getting it right. It's not going to be the case like when we were doing for parallel. For parallel, it was straight, VA minus VB. But in this case, since they are inclined, you need to actually do some processes, especially by manipulating the observer by first reversing it. Then you now connect its head to the tail of the one that you are observing. Then you complete the right angle triangle such that the resultant starts from the tail of the observer to the head of the one we are observing. Okay, so and I have 4 over 3, right? 4 over 3. So I got theta. Theta, the answer for theta is equal to 53.13 degrees. So this is the direction. So the observer, right? The relative velocity is a magnitude 5 meters per second, 53.13 degrees from B, at an angle 53.13 degrees from B. That's it, right? Um, so that's the first question. Yes, that's how to find the solution. You need to find this. You have to find the magnitude and find the direction. We are dealing with what? A vector quantity. So we needed those two. Let's solve another question like this one. They say A is moving due south, 2 meters per second due south, and then B is moving 4 meters per second due south. So we have to find the velocity of B to A. Right? This one, let's reverse this. Now A is now the observer. Okay. But we need to represent this one. Due south. South is down, right? A is south. So VA. Now VB is what? Due west. And west is towards this. But we are finding VBA. This is represented as VBA. And this one, the mathematical representation that we did, VB minus VA. Because they are not parallel, right? We cannot plug in the values directly. But because they are inclined, we need to actually manipulate the observer. So the observer, we need to find negative VA. This VA going down, right? If you want to negate it, you have to change the direction. So it's now going to be going up. If it's going down, then it goes up. This is negative VA. It is this negative VA that will attach to the observer, the body that we are observing. So this is VB, but we need to connect the observer such a way that after reversing it, his head is connected to the tail of this guy. So it's going to be like this. So I have negative VA here. And now we have it. Now we need to complete the right angle triangle and move the arrow. On a resultant, the resultant is always having double arrows, as we said in previous sessions. So yes, so from here to here is going to be our resultant. And then we need to find, this is going to be VBA. And after finding it, you need to make sure that you find the angle theta between the observer and the resultant that we are going to find. And this one we use tan theta. Okay, let me represent this on another quickly here for you. And then we had this negative VA, this is VB, and then I complete this like this. Understand the process. If not, you and then we need to find this theta. How do you find? So this is VAB. VAB is the hypotenuse of the right angle triangle that we obtain. So VAB is going to be VB is having a value of 4, and then VA is having a value of 2. So it's going to be square root of 4 squared plus 2 squared. So 4 squared plus 2 squared. So when you do this, right, you are going to have square root of 20. Square root of 20 is 2 root 5 meters per second. So this is VAB. You can put in the calculator and get the decimal value, right? Stop at the 2 decimal places. Yeah, so this is what we have. But then we need to find the theta. What is the theta? Theta is going to be tan inverse of the opposite over hypotenuse. Opposite over adjacent. The opposite is 4, and then the adjacent is 2. So tan inverse of 2, right? Tan inverse of 2. So I got 63.43 degrees. So this is having a direction of 63.43 degrees. So yeah, the body A is observing the body B to be moving with a velocity of 2.5 meters per second at an angle of 63.43 degrees. Right? Yeah. In that particular direction. Yeah. So yeah, in the next session we'll be looking at how to find the velocity of the relative velocity of two bodies that are inclined at an angle aside 90 degrees. They are now inclined at any other angle. They are not parallel and they are not inclined at 90 degrees, but they are inclined at any other angle, right? Now we'll look at that case and then see how to go. It's going to follow the same thing like this one, and it's going to be involved more things. So let's stay in touch and follow for the next session. See you there.